This is a calculator from the 1960s. When I press the keyboard, I can enter numbers one by one. This seems to be taken for granted, but thinking from a different angle, the numbers in the same position are constantly changing. This calculator uses Nixie tube technology. If we break the outer glass of a Nixie tube and look at the internal structure, we will find that it stacks each number insulated from each other. When a specific number needs to be displayed, it lights up that number. The order of the stacked numbers is also particular. For example, this Soviet Nixie tube in my hand arranges the numbers in the order of 3, 8, 9, 4, 0, 5, 7, 2, 6, 1. But the more common order is 6, 7, 5, 8, 4, 3, 9, 2, 0, 1. These sequences reduce obstruction as much as possible, making the lit number easier to recognize. It's really complex. Is there a more ingenious way to display different numbers in one position? This is a calculator launched in 1974. It also uses Nixie technology to display numbers. But instead of stacking all numbers together, it uses a special style, the segment display. The most common segment display is the 7-segment display. It uses 7 segments to form a rectangle with a horizontal line in the middle. By combining different segments, it can effectively display numbers from 0 to 9. The most common 7-segment display looks like this now. Everyone should be very familiar with it. But can the segment display only show numbers? We enter 0.7734 on the calculator and flip it over. It shows hello. Of course, it can be less friendly too. Entering 7734206 and flipping it over shows go to hell. This word game of turning segment displays into letters to convey messages is called begalos. Why this name? Because the digits 0 to 9 in a 7-segment display only form these letters when turned into letters without ambiguity. In an era when phones couldn't freely send text messages, people used numbers to replace similar-looking letters. For example, entering 6, 0, 0, 0, 8, 4, 3 to say goodbye to a friend, or combining numbers to represent letters, like using 1, 7, 7 for the capital letter M, resulting in I miss you. You can try guessing what this code means. Of course, software can freely display more than just numbers. For example, A, B, C, D, E, F. Using lowercase for B and D because uppercase B or D would confuse with 8 and 0. Even if it sacrifices some aesthetic and readability, some letters like W, M, G are hard to display accurately. We can see various word visual issues on devices, like the word light. The gap between L and I is large, which is unavoidable. Western lowercase letters have ascenders and descenders, like G and H here, which look awkward in a 7-segment display. However, some words look excellent, like error. Capitalized first letter, uniform letter spacing, no ascender or descender issues. Perfect. If you must display letters like M or T, what to do? This is a small clock. Notice anything different? The hours and minutes in the front are normal 7-segment displays, but at the end, the middle horizontal line is split into 2, with 2 more vertical lines in the middle. To display a capital T in a 7-segment, the vertical line must be on the left or right, sacrificing the top half horizontal line. Adding 2 vertical lines creates the most common 9-segment display. The vertical line can now be centered. Letters like M, W are solved by this vertical line addition. But this solution isn't perfect. For example, the letter R looks awkward. Looking at the last letter of the clock, its bottom part uses a diagonal design, allowing the letter R to be perfectly displayed. This diagonal line doesn't affect other letters' performance in the second position. This is a classic design. The 9-segment display is very useful. If you need to display more letters in one position, the more complex cross-grid 9-segment display is used. It can display uppercase and lowercase Latin letters. Although the ascender and descender issue remains unsolved, some have designed a 22-segment display for this. When the segment display becomes this complex, it's less meaningful. The cross-grid structure segments are functional enough in most cases. For example, this walkie-talkie uses the cross-grid structure. You can see English words displayed clearly. Some even thought of using cross-grid 16-segment code to display Chinese characters. I simulated it. Characters like jia, yi, bing, ding, or displaying Chinese numbers, or some simple functional content. Attentive viewers might have noticed, common segments are straight, but also can be slanted, giving it a different aesthetic. But people's artistic pursuit for segment displays didn't stop at simple slanting. For example, this 1969 Sharp calculator used creative designs and layouts to display handwritten style numbers, one of my favorite segment displays. It's worth mentioning that in this style, the number 0 can only be half height. This even influenced fluorescent tube calculators later on, like this 1973 Casio calculator of mine. Even though the 7-segment can display full height 0, it still chose to show half height. This half height 0 became a retro feature of that time. The artistic creation of segment displays never stopped, especially in watches with fashion and decorative attributes. I love collecting them. Over the decades, you can see various unique segment display designs. The times gave designers a challenge, and they worked hard to break homogeneity, seeking breakthroughs. The exact appearance and creator of the 7-segment display are unknown, but it can be traced back to the early 20th century. More than 100 years later, segment displays are still widely used. But with the popularization of pixel displays and the reduction of costs, people no longer care much about the visual design of segment displays. Maybe one day, segment displays will be phased out and become history. But if you're willing to look, evidence of their past glory is everywhere.